Just a couple of reminder facts before we get started. If this is a right angle, it means it's 90 degrees, and I draw an angle in here, call it A, and this angle here, B. If I take the measure of angle A, add that to the measure of angle B, and I get 90 degrees, then these two angles are complementary. They're complements of each other. So complementary angles add, their measures add to 90 degrees. Now, if I take an angle A and an angle B, and they give me a straight line when I put them together, if I do this, if I take the measure of angle A and add that to the measure of angle B, and that comes out to 180 degrees, then A and B are said to be supplementary, and they're supplements of each other. So complementary angles add to 90 degrees, their measures do, and supplementary angles, their measures add to 180 degrees. So in this first problem we'll look at, find the measure of the complement of a 64-degree angle. Now I want the complement, so I know this. I know that if I take 64 degrees and add it to its complement, which we don't know just yet, that'll give us 90 degrees. And now let's just subtract 64, right? So we're going to subtract 64 degrees, and by doing so, we're going to get 26 degrees. So let's write that. So x equals 26. So the complement would measure 26 degrees. Not x equals 26, but 26. So now we want to find the supplement. Back in number 1, we found the complement. Those are two angles whose measures add to 90. Now we want to find the supplement of an angle who's already 143 degrees. So what we're going to have is 143 degrees plus x, some angle measure. That's equal to 180. 180 because they're supplements. So why don't we subtract 143 degrees, and 180 minus 143 is 37. So we're going to say the measure of that supplement is 37 degrees, and you know we don't need that x. We're just going to say the measure of the supplement is 37 degrees. In this problem, we're given two lines and they intersect at B, and we're asked to identify all of the acute angles. So what we want here are the acute angles, and an acute angle is an angle with measure less than 90 degrees. So let's look at all these angles. What about, I'll just start here and maybe go around. What about this one here, CBE? All right, now that looks to me like it's less than 90 degrees, so we're going to say that we have the angle CBE. What about this one here? This looks more than 90 degrees, so we're not going to include that. What about this one, ABD? Let's include that, so angle ABD. And then what about this one here, DBE? That looks more than 90 degrees. So just if we go with the picture, I'm going to claim that these angles here, these two angles are the only acute angles. When I made this drawing here in problem number 4, I did not write these to scale. You know, this is 25 degrees. Clearly this is 3 times as big, but it doesn't look like that on my picture. So what we want to do is identify complementary angles. So let's start over here. Now complementary angles, we know their measures add to 90. So I've got 25 degrees. Now are there any of these that if I add to this, I get 90? Well, how about this one? 65 and 25 is going to give us 90. So there's a pair. So that would be angle. Now it goes like this, POQ. POQ. So I'll write POQ, or if you like, QOP. And that one's going to go along with angle. Now it was this one here, right? SOT. So that's going to go with SOT. Now, we started here. Let's move up to this one, 75 degrees. What about this one, or this one? These two. Do either of these numbers with 75 add up to 90? Well, they do. 75 and 15 is a 90, so that's going to be this angle, QOR and ROS. So let's note that. So what do we say? It's going to be angle QOR and angle ROS. So in problem 5, we have this picture here, and we're given some information about these angles. And what we want to do is use this information with this picture here to determine the measure. Here's what we're trying to get. Let's get the measure of angle FDC. So FDC. We're looking for the measure of this angle right here. Let's note that. So that's going to be the one that we're looking for. Now, this first piece of information says that CE, now that's the line CE, is perpendicular to this line here, DG. All right, so we do know this. We do know that that angle right there and right there, those are 90-degree angles. Right? Those are 90 degrees. So that means these angles are at 90 degrees to each other. And then also, HD, here's HD, that's perpendicular to FD. So this angle and this angle right here is 90 degrees. Let's mark that, a big 90 degrees. So we've got a 90 degree there. You know, I think I mislabeled this. This is not DEF, but rather EDF. That's 66 degrees, right? Now let's look at that angle. EDF. EDF. I wrote DEF. That doesn't make any sense. DEF. The middle number is always the vertex. So EDF. EDF. And we are given that that angle is 66 degrees. So EDF, right here, this is 66 degrees. So we're looking at 66 degrees. Let's mark that. 66 degrees. Okay, now let's look at this here. What about this angle right here? From here to here, this angle is 90 degrees, and this angle is 90 degrees. So these two angles here, this one and this one, are supplementary. They add to 180. Now I know this one is 66, so this one is what's left. So I don't think we even need all this other stuff unless I'm looking at this thing wrong. But I'm going to see that the measure of angle EDF plus the measure of angle FDC, that's 180 degrees. Let's just look at those again. It's EDF, now that's 66, and FDE, because it's perpendicular, 90 is 180. So these are supplementary. And then if we say that this one is 66 degrees plus the measure of angle FDC, which is what we're looking for, is 180 degrees. If you subtract 66 degrees, we're going to get that the measure of angle FDC is, okay, 180 minus 66, I got 114 degrees. Now, to do this problem here, we're going to have to assume that this line right here is horizontal, that it's a straight line. So if this is 130 degrees, then right here, this is going to have to be 50 degrees. Now, we are trying to find the measure of angle 4. Angle 4 is up here. So we've got this as 50, and then we're given this information, that angle 1 is equal to angle 2. So if we use that information, that angle 1 equals angle 2, and we just found that angle 1 is 50 degrees. Let's put a 50 here. We'll have 50 is equal to angle 2. So now we have that angle 2 up here, that's also 50 degrees. So now I can take that angle 2 and make that 50 degrees. Now, here's a fact that we need to know. If you take two lines like this, these angles right here, this one and this one, these are called vertical angles. These are called vertical angles, and vertical angles have the same measure. So whatever measure this is the same measure. Now we're going to use this idea up here, right? We started with 130, that gave us this is 50, but then angle 1 and angle 2 were the same, that was given, so this is 50. Now look at this angle 4, that's a vertical angle. 2 and 4 are vertical angles, so this is 50, angle 4 is 50. So let's just write that then. So angle 4 is equal to 50 degrees. So here in problem 7, we're given that these two lines are perpendicular to each other. Let's see if I can draw that. These are perpendicular to each other. So we know that this measure right here is 90 degrees, as well as this one right here. All through here, x plus angle 1, that's 90 degrees. So in this case, we're given that angle x, the measure of angle x is 26 degrees. And what we want to try to do here is to find the measure of angle 3. So we're looking to find the measure of this angle. Now we know this one is 26. So what is angle 1? Well, here's what we do know. And the measure of angle x we're given is 26 degrees, plus the measure of angle 1, that's 90. So if we subtract 26, we're going to get that the measure of angle 1 is equal to 90 minus 26, 64 degrees. Now look at angle 1 and angle 3. I'm going to draw them down here. Okay, here's angle 1, here's angle 3. These turn out to be vertical angles, and vertical angles have the same measure. So if we know that the measure of angle 1 is 64 degrees, it must be that the measure of angle 3 is also 64 degrees. So in this problem, we're going to have to assume that these two lines are parallel. And if we have parallel lines, this line that crosses parallel lines, this is called a transversal. Now these angles here, I'm going to take this angle here, angle 1, and that's an and sign, and angle 4, these are called corresponding angles. They correspond to these positions here. They have kind of the same position. So those are corresponding angles. Here's another pair. How about angle 2, right, angle 2, and then you come down here and you also see angle 5. So and angle 5, those are corresponding angles. So in problem 9, we're told that lines that appear to be parallel really are parallel. So this line here appears to be parallel to this line. The two horizontals appear to be parallel, and they are. That's what we're told. And these two slanted lines here, this one and this one, they appear parallel, and they're telling us that they are parallel. And what we want to do is we want to find the measure of angle 1. So here's what we know. Now we're going to have to, we'll know this, I'm going to tell you, but also it's in the book, is that look at this angle here. This is 58 degrees. Now these angles right here, these are vertical angles. I'm going to call this angle, let's give it a name here so we have something. Let's call it angle, we got 1, 2, 3, let's call it angle 5. So what we're going to know is this, that angle 5 is equal to 58 degrees also, because these are vertical angles. So we know that that's true. Now, let's talk about these alternate interior angles. You know, back over here in problem number 8, we talked about corresponding angles. Corresponding angles would be 1 and 4, because they kind of have the same position here. They're both these acute angles. And then 2 and 5, they both have that kind of outside position, those obtuse angles. But alternate interior angles, these are going to be angles on the interior that are alternate. They alternate on sides of the transversal. So how about 1 and 5? These are alternate interior. This one, alternate with this one, right? They're both interior, but they're on alternate sides. So what we know is that they have the same measure. So now we know that the measure of angle 5 is equal to the measure of angle 1, but we just determined that the measure of angle 5 is 58 degrees, so that's the measure of angle 1, and we have what we're looking for. Well, let's see what we can do in this problem here. Here's what we're given. down here we're told that BF is parallel to CE. So here's BF. This little segment here is parallel to this segment. So those are parallel. And then we're given that FC, here's FC, that's perpendicular to AD. So these two lines here are parallel. This segment here is parallel to this line, is perpendicular to this line. Now we're also told that angle ABF right here is 149 degrees. So we can note that that's 149 degrees right there. Now what we're trying to do here is we're trying to find the measure of this angle, FCE. Here's FCE. So we're looking to get this measure right here. What is that measure? All right, let's see if we can play around with this and see what we come out with here. Now we know this. This is 149 degrees, so because this is a straight line, this supplement right here, that this measure plus this measure has to be 180. So what we're going to get from here is this is 180 minus 149. All right, so I'll write that down over here. Let's keep track of it. It's going to be 180 minus 149. Now that turns out to be 31. So this angle here has a measure of 31 degrees. Now we also are given this, that this angle right here is a right angle, right? Because they tell us that this segment is perpendicular to this, so that must be 90 degrees. And now look in this triangle here. We've got this triangle right here, here, and here. And we know this, that the interior angles of a triangle, their measures add up to 180. So this number plus this number plus this number must be 180. So what we're going to have is this number must be, right, this plus this has to be 180. So what we can write here is we're going to get 180 minus the 90 minus the 31, and that gives us 59. So this angle right here, we're now going to claim to be 59 degrees. And now look what we've got. This line here is parallel to this line. This is parallel to this, and here's a line that cuts through parallel lines, so it's a transversal. And we know this, that on a transversal, alternate angles are equal. This angle is alternate to that angle. They're on alternate sides, and they have equal measure. So we can now conclude that angle FCE, right, this one, FCE, this angle has the same measure as that, which is 59 degrees. Here in problem 11, the last one we're going to do, this is supposed to represent a bridge. Here's the base of the bridge, the top of the bridge. These are supporting poles, and these are supporting cables. And we're told in the problem that lines that appear parallel are parallel. So we're going to assume now that, say, FE at the top is parallel to AD right there at the bottom. Right, we're assuming this segment here is parallel to this segment, that these two are parallel. So let's write that in. So BF is parallel to CE. And also, we are told that this line here is perpendicular to this one. This one's perpendicular here. All right, so we know that what we've got are 90-degree angles here and here, as well as up at the top. And what we want to do is we want to find the measure of angle CDE. So here's CDE, CDE. I'll put it in yellow here. Here's the one that we're looking for. We're looking for this one right here. Now, we are given some information. We're given that this angle down here is 43 degrees. This one over here is also 43 degrees. And this one up here is 94 degrees. Now, I think we can do this pretty directly here. Here's what I'm looking at, although it doesn't look like it in my picture here. But FC, or this segment right here, although I didn't write it, is parallel to this one. If they appear parallel, they are parallel, we're told. Now, it doesn't look like it in my picture. But this segment here is parallel to this one. That means that this line here is a transversal. This is a transversal. And what we have is this angle here and this angle. These are corresponding angles. And corresponding angles, I know, are equal in measure. So this angle here and this angle here, these are corresponding angles. And corresponding angles have equal measure. So we're going to conclude now that that's what we're looking for. We're looking for this one. That's going to be the same measure as that 43 right there. So that's going to be 43 degrees.